In this video, we're diving into an essential aspect of the Zig programming language, its built-in functions. Specifically, we'll be discussing a fascinating built-in function that returns the natural logarithm of a floating point number. This function harnesses a special hardware instruction for optimization when it's available, making it an efficient tool in your programming arsenal. So far, we covered the built-in memory functions of Zig, like @memp, @memset, and @memove, which enhance memory manipulation. With a firm grasp on those essential tools, you're already well equipped to improve efficiency and safety in your projects. Now let's turn our focus to mathematical operations, specifically logarithmic functions, and understand how Zig simplifies complex calculations with its built-in capabilities. Now let's see how we can implement the natural logarithm function using Zig's built-in capabilities. In this snippet, we start by importing the standard library, which provides essential functionalities like the debugging print function. The main function is defined next, where we declare a constant floating point number set to 10. This number will be the input for our logarithmic calculation. We then make a call to the @ln function, passing our number as an argument. This operation computes the natural logarithm of our specified number using Zig's efficient implementation. After calculating the logarithm, we store the result in the variable natural log. Finally, we employ the std debug print function to output the results to the console, formatted to show both the original number and its corresponding natural logarithm. When executed, this code will display that the natural logarithm of 10 is approximately 2.302585, illustrating how easily Zig allows us to perform mathematical calculations while keeping the focus on algorithmic logic. This example serves to reinforce the simplicity and clarity of utilizing Zig's built-in functions for mathematical operations. Now let's see how we can efficiently compute the natural logarithm of multiple numbers using the @ln function. First, we define an array of positive floating point numbers containing 5 elements. This array will serve as our input for logarithmic calculations. Next, we utilize getStdout writer to set up the standard output, allowing us to print the results to the console. We then iterate over each element in the numbers array with a loop. Inside the loop, we check if each number is greater than 0, since logarithms are only defined for positive values. If the condition is satisfied, we calculate the natural logarithm using the @ln function and store the result in the natural log variable. Following the calculation, we use stdout print to display the number and its corresponding logarithm. In cases where the number is non-positive, we print a warning message indicating that the logarithm cannot be computed for the given input. This approach not only demonstrates how to use the @ln function effectively, but also emphasizes the importance of input validation in programming to prevent runtime errors. Now let's see how we can implement the calculation of logarithmic returns based on a series of stock prices. We start by defining an array of stock prices, which in this case includes 5 different values reflecting the price of the stock over time. The code utilizes Zig's standard library to access I/O functions, allowing us to print to the console. Next, we iterate through the prices using a loop that goes up to the second to last price, allowing us to access both the current price and the next price in the sequence. Inside the loop, we calculate the logarithmic return by taking the natural logarithm of the ratio of the subsequent price to the current price. This is done using the built-in @ln function, which efficiently computes the natural logarithm. Finally, for each price pair, we print the current price, the next price, and the computed logarithmic return. This approach not only facilitates the tracking of stock price changes, but also provides insight into the percentage changes while factoring in volatility. Through this implementation, we leverage Zig's built-in capabilities to perform essential financial calculations quickly and effectively. While we've concentrated on @ln for the natural logarithm, Zig has several other built-in mathematical functions that can also streamline your coding experience. Functions such as @sqrt for computing square roots and @exp for computing the exponentials of numbers can be equally essential. For instance, suppose we want to calculate the exponential growth of an investment after several compounding periods. This can be achieved easily using the @exp function along with our logarithmic functions to determine growth factors. Now let's wrap all this up with a deeper understanding of why using built-in functions like @ln is beneficial. When utilizing these functions, you're not just gaining access to mathematical capabilities that are directly expressed. You are also taking advantage of the underlying efficiencies provided by the Zig language, making your code not only cleaner but more performant. It's clear that mastering these built-in capabilities can vastly improve how you approach mathematical problems in programming. You will not only learn how to do complex calculations, but will also understand how to do them efficiently, guarding against common pitfalls like non-positive inputs. As you incorporate these practices into your projects, you will find that your ability to solve mathematical problems in code becomes much more adept and robust. In summary, we delved into the capabilities of the @ln function for calculating natural logarithms in Zig. We examined practical usages, explored underlying optimizations that enhance performance, and even touched on applications in financial modeling. Armed with these insights, you're better prepared for building sophisticated applications that require mathematical computations. Keep leveraging these built-in functions and let them serve as the powerful tools they are in your programming toolbox. Thank you for joining me in this exploration of Zig's built-in functions. Don't forget to practice with these examples and discover new ways to apply logarithmic functions in your projects. Happy coding!